Imagine you need to measure the coastline. You might think it's a simple task. Sounds easy, right? Just grab a ruler and a map. But is it really that straightforward? But wait, what happens when you look closer at the map? You start to notice more details. You see more details, more little bays, and more curves. The coastline becomes more intricate. Suddenly, your ruler doesn't seem good enough. The more you zoom in, the more complex it gets. This, my friends, is the Coastline Paradox. It's a fascinating concept that challenges our understanding. Coastlines, those beautiful edges between land and water, have a fascinating secret. They are not as simple as they seem. Their length isn't set in stone. It changes with the level of detail you observe. It changes depending on how you measure it. The tools and methods you use can alter the results. The more carefully you measure, the longer the coastline seems to get. It's almost like a never-ending puzzle. This strange idea shows us that our usual way of measuring things has limits. It pushes the boundaries of our understanding. It reveals a world where straight lines become incredibly complex. A world where simplicity turns into complexity. This isn't just something that scientists think about, it's a concept that has real-world implications. The coastline paradox is important in the real world. It affects how we manage and interact with our coastlines. It affects how we take care of coastlines, sail the oceans, and even understand how complex things can be. It's a key to unlocking deeper insights. So, get ready as we explore this amazing paradox. It's a journey of discovery and wonder. It's a journey that will take us from the edges of maps to the amazing world of science. Join us as we unravel the mysteries of the coastline paradox. The coastline paradox reminds us that the world doesn't always fit into our neat and tidy boxes. It challenges our basic understanding of measurement. We expect a coastline, like any other line, to have a fixed length. But coastlines are different. They're rebels, breaking the rules with their incredible details. Think about it. A coastline isn't a smooth, unbroken line. It's a messy mix of inlets, bays, peninsulas, and rocks, all woven together like a beautiful tapestry. As you look closer, you see even more detail. Tiny coves and jagged cliffs appear, each one adding to the overall length. This is where the paradox comes in. The closer you look, the more you find. The length of the coastline seems to go on forever, limited only by how closely you measure it. It's like trying to measure the edge of a cloud, an impossible task. The coastline paradox wasn't always a paradox. It began as a simple observation that puzzled many. It was a puzzle, waiting for the right person to solve it. Many had noticed the oddity, but no one had delved deep enough to understand it. Enter Fry Richardson, a British mathematician who loved curious and unusual things. His inquisitive nature led him to explore many scientific mysteries. In the early 1900s, Richardson came across this strange phenomenon while studying the relationship between the length of borders and the chance of war. He noticed something odd. The lengths of borders varied significantly. The reported lengths of borders were very different depending on where he looked. This inconsistency intrigued him. Curious, he decided to investigate further. He wanted to understand why these measurements were so inconsistent. He focused on the Iberian Peninsula, carefully measuring its coastline using maps of different scales. He meticulously traced every curve and indentation. To his surprise, he found that the smaller the scale of the map, the longer the coastline seemed to be. This was a revelation. Richardson's careful measurements revealed a fundamental truth about coastlines. Their length depends on how closely you look at them. The more detailed the map, the longer the coastline appeared. The more you zoom in, the more details you uncover, and the longer the coastline becomes. This was a groundbreaking discovery. This groundbreaking observation laid the foundation for our modern understanding of the coastline paradox. It showed that measurement is not always straightforward and can depend heavily on the tools and scales we use. While Richardson discovered the paradox, it was Benoit Mandelbrr, a French-American mathematician, who gave us the key to understand it. Mandelbrr, the father of fractal geometry, saw in the coastline paradox a deeper principle at work in nature. Fractals, those mesmerizing shapes that repeat themselves at different sizes, provided the perfect language to describe the complexity of coastlines. Just like a fractal, a coastline shows self-similarity. Its intricate patterns repeat themselves at smaller and smaller scales, creating an endless amount of detail. Mandelbrot's insights revolutionized our understanding of shapes in nature. He showed us that nature is full of fractal forms, from coastlines and clouds to trees and blood vessels. These shapes, once considered too irregular for traditional geometry, found their rightful place in mathematics thanks to Mandelbrot's groundbreaking work. Section 5. Measuring Mayhem, Norway's enigmatic coastline. Let's look at a real-world example of the Coastline Paradox in action, Norway's amazing coastline. Norway, a land of majestic fjords, countless islands, and a coastline that seems to go on forever, is a perfect example of the paradox's confusing power. Norway's coastline, when measured with increasing precision, seems to grow endlessly. Its countless fjords, those deep narrow inlets carved by glaciers, add an extra layer of complexity. Each fjord branches off into smaller inlets, creating a maze of waterways that are difficult to measure. The official length of Norway's coastline varies greatly depending on the source and the method used. Some estimates put it at over 15,000 miles, while others claim it's closer to 60,000 miles. The true length, however, remains a mystery, a testament to the Coastline Paradox's enduring puzzle. Section 6. A ruler's nightmare. Why measuring coastlines is so tricky. Measuring coastlines is like trying to nail jelly to a wall, a frustrating and impossible task. The coastline's inherent complexity and scale-dependent nature make even the most precise measurement attempts difficult. Imagine trying to measure a coastline with a ruler. You'd constantly encounter curves, inlets, and protrusions that don't fit neatly against your straight edge. You could try to approximate, but you'd inevitably miss some details. Even with advanced technology like GPS and satellite imagery, measuring coastlines remains a challenge. These tools can provide incredibly detailed data, but the question of which details to include and which to ignore persists. The Coastline Paradox reminds us that measurement is not always as straightforward as it seems. It's a humbling reminder of the limitations of our tools and the inherent complexity of the natural world. Section 7. From Maps to Reality: Practical Implications of the Paradox. The Coastline Paradox isn't just a theoretical curiosity, it has significant real-world implications that extend far beyond academic discussions. It affects many fields, from map-making and navigation to coastal management and environmental conservation. Professionals in these areas must grapple with the paradox's complexities. For cartographers, the paradox presents a unique challenge. They must decide how to depict coastlines accurately on maps. How do you accurately represent a coastline on a map when its length is inherently ambiguous? This question is at the heart of their work. Mapmakers have to make choices about the level of detail to include, knowing that their representation will always be an approximation. They must balance detail with usability. In navigation, the Coastline Paradox highlights the importance of using charts with appropriate scales. Mariners rely on these charts for safe passage. A chart that's too small might not show crucial details, potentially leading to navigational hazards, while a chart that's too large might be cluttered and difficult to use, making navigation more challenging. Understanding the Coastline Paradox is also essential for effective coastal management. It informs decisions on how to protect and develop coastal areas. Accurately assessing the length and complexity of a coastline is crucial for planning infrastructure, managing erosion, and protecting sensitive ecosystems. This knowledge helps in creating sustainable solutions for coastal challenges. Section 8. Beyond the coast. The paradox in unexpected places. The Coastline Paradox, while rooted in the realm of geography, extends its reach far beyond the edges of continents and islands. It pops up in unexpected places, revealing the interconnectedness of seemingly disparate phenomena. In biology, the paradox helps us understand the complexity of biological structures like blood vessels and lungs. These structures, like coastlines, exhibit fractal-like patterns that maximize surface area within a limited volume. In astronomy, the paradox finds an echo in the distribution of matter in the universe. Galaxies cluster together in vast filaments and voids, creating a cosmic web that resembles a giant, intricate fractal. Even in the realm of music, the paradox makes its presence felt. The intricate melodies and rhythms of certain musical genres like jazz and classical music can be analyzed using fractal geometry, revealing hidden patterns and complexities. Section 9. The Universe in a Grain of Sand, Embracing the Infinitely Complex. The Coastline Paradox, in its elegant simplicity, reveals a profound truth about the universe. Complexity is often hidden in plain sight. It teaches us that the world is full of wonders that defy our attempts at neat and tidy categorization. It reminds us that measurement, while a powerful tool, has its limitations. It can't always capture the full richness and complexity of the natural world. Sometimes the most we can do is marvel at the intricate dance of order and chaos that surrounds us. So the next time you find yourself gazing at a map or standing on the edge of a continent, remember the Coastline Paradox. Let it remind you that the universe is full of surprises, and that the beauty of the world often lies in its infinite complexity.